welcome back. So today let's look at a new chapter. So in this figure you can see a house, right? So you are seeing a house. And now can you find out the geometrical patterns that you are seeing here? There are so many small lines that is drawn there. If you take this particular portion, you will get so many line segments. See, if you take the door, it's a rectangular shape, and in that rectangular shape it's a intersection, it's a combination of 4 lines if you say that. And also in here you are getting an acute angle, a 90-degree angle there. So you are seeing so many angles, so many lines in this figure. So in today's class we'll be discussing on lines and angles. So, sorry for the disturbance. Okay. So now what is this figure? Can you see this one? This figure, what is this figure? So are you telling me this is a line? Let's see. Then what about this one, the second figure? So which one is a line? The second figure is a line. The first one is having 2 end points. So the first one is a line segment and the second one is a line. A line is straight, no bends, and it has no thickness. So the width is, there is no width for a line, and it extends in both directions. In Euclid's geometry chapter we saw that a line has only one dimension, that is a point is required. The point is the only thing that is required to describe a line. So a line has no thickness, it extends in both directions, it is straight. So you all know this from your early classes, like recalling all these things. Now what is a line segment? A line segment is a part of a line with 2 endpoints. So a part of a line with 2 endpoints is called a line segment. Now what about the third figure? This one, there is one arrow and there is an endpoint. This is nothing but a ray. So a ray is part of a line with one end point. So part of a line with one end point is called a ray. So one side of ray will be extending, it will be going on. So tell me where you have heard about rays except in mathematics. You have heard about UV rays, you have heard about sun rays. So why do you think you call the light from the sun as rays? Can you give me a reason? So the rays are starting from the sun. The light is starting from the sun. Sun is fixed. So there is an end point for this. So that's why we represent rays for the sunlight, for the light, for any light you will be using rays. To show its position, its magnitude, its direction, as well as to, especially in the case of sun, we will be using rays because sun is kept fixed there. So there is one end for this light. The starting point is always fixed, it's sun. So there is a fixed point. So it is called as a ray. Now let's look at for a second. So let's look at, in the last class also we saw what is the difference between a line segment and even a ray. So let's see. Now this is a ray. So let us take a line. So in a line this can be extended. See, these points, they can move like this. So a line is never ending, it is straight. You can see this is straight. There is no curves, no bends, and it has no thickness. So you can go on and on in both the directions in a line. What about a ray? So in a ray you can move in one direction. The other end, it is fixed. See, A is fixed. Then what about a line segment? So in a line segment, both the end point, there are both two endpoints and it is fixed. So I hope you understood what is all this. Now let's move back. Now can you see 3 points here? A, B and C are 3 points. Now can you tell me a property of these points? They are lying on a straight line. So this is a line and these 3 points A, B and C are lying on this point. It's this line. So what about the other collection, the next collection? See, this is 1 point, this is 1 point, this is 1 point, this is 1 point. They are scattered all around, right? So if you try to draw a line connecting all the points, is that possible? So if I try to draw it like this, it will go like this. Only 2 points are getting connected. So if you try to draw like this, sorry, if you try to draw like this, or if you try to draw like this or like this, sorry, I'll correct it. Okay, so if I try to draw a line through these points, it's possible, but what about the next two? It will be left out. So if I try to draw a line like this, it's again going to through 2 points. So I can draw a line to these 2 points also, but I can't draw a line connecting all these points like what happened in this case. See, all the 3 points are in a straight line. I can draw a polygon, I can connect them, it becomes a polygon, but it is not in a line. So if for the first figure, for these points we call them collinear points. So linear, the word linear represents, it means that thing is related to line. So linear means related to line. So if 3 or more points are lying on a line, we call them collinear. So we won't use this hash, so we will be using collinear. We will write it just like this, collinear points. So A, B and C are collinear points. So what can you say about these points? They are non-collinear points. So like as I said, linear, the word linear is related to line. So if you have already heard about, this one, linear equations. In there, geometrically it means that the equation can be represented as a line. So whenever you hear about linear, you just imagine that, just imagine in your memory, or this should come in your memory, that the linear, it means that geometrically when we draw the figure, it will be a line. So I hope you understood all these points. So if 3 or more points lie on a straight line, they are called collinear, and otherwise they are called non-collinear. Now angle. So what is an angle? How is an angle formed? An angle is formed when 2 rays originate from the same point. So here we have the vertex. This point is called the common point and we call it as a vertex. You have already known all these things. So this point O is the vertex, it's a common point, and there are 2 rays starting from O. So let's name it as A and B. So A and B are there. This is the vertex, and these rays are called arms, and an angle is formed between. So when you move one arm, you will get an angle like that. If you are trying to move it around, you will get an angle completely. So an angle is formed when 2 rays originate from the same point. So the rays making an angle are called the arms of the angle, and the end point is called the vertex of the angle. So the end point is called the vertex and this is called the arms. Now you have already heard and learned about all these angles. Can you tell me what is the first figure? What is the angle here? So this could be less than 90 degree and it is greater than 0. So this is nothing but an acute angle. What about this one? It is 90 degrees. So it will be a right angle. What about this figure? Here this angle is greater than 90 degree and it is less than 360 degrees. So it is an obtuse angle. So in this figure it is lying on a line, the angle is straight. So it is 180 degree. Now this is a straight angle, and what about this? Here, So till here it is 180 degree. So it is greater than 180 degree and it is less than 360 degree, a complete angle. So this angle is called a reflex angle. So types of angles: acute angle, right angle, obtuse angle, straight angle and reflex angle. Description: acute angle is less than 90 degree, right angle is always 90 degree, obtuse angle is greater than 90 but less than an 80 degree, straight angle is 180 degree exactly, and reflex angle is greater than 180 degree. Now let me show you. So here you can see that okay, let it respond. Okay, by that time let's talk about angles. So yeah, so we are here, we have so here there is a point A, that is the vertex, and from A two rays are going. Okay, so two rays are there. Now I think you can see clearly. Yeah. So now see what happens to the angle. The angle formed. Okay, let me start. So now the angle let us round it to be 0. So now there is no angle formed. So the two rays are coinciding. So now I am moving one ray. So I am moving one ray. So you can see an angle 10 degrees formed in between the two rays. From here you can see that. Now when I am moving, see, the angle is formed like this. Now what kind of angle is this? Angle is 55 degrees. So it is less than 90 degree, it is called an acute angle. Now I am moving again. So let's see. Now the angle became 90 degree, that is, it is a right angle, and now I am moving again. So it is greater than 90 degree, and now it is an obtuse angle. It is greater than 90 and it is less than 180. Now what happens when it is 180 degree? Is 179 degree, that is also an obtuse angle. What about 180? Yeah, 180. So now you can see that they are perfectly in a line. So this angle is a straight angle. Now it is greater than 180 and less than 360 degree. So it is a reflex angle. And now what is happening? It is again a reflex angle, and now it is a complete angle. So it is 360 degree. I hope you understood all this. Now let's go back to our collection. Okay then. Okay, so now, so here we have in the figure two angles, 40 degree and 50 degree, and look at the sum. The sum of these angles is 40 plus 50, 90 degree. So, two angles whose sum is 90 degree are called complementary angles. So, what is a complementary angle? It's a pair of angle, okay, not that this is a pair of angle. We always say complementary when you have two angles and when their sum is 90 degree. So, in this figure they are together. So, is it necessary for two angles to be complementary and they have to be like this, like the figure? They have to have something common. It is not necessary. We can 90 degree and 63 degree. The sum is 90 and these angles are called complementary angles. Now, look at this figure. So, here 40 degree and 140 degree. Then the sum is 180 degree. So, in the second case 60 degree and 120 degree. Again the sum is 180 degree. In that case we will call it as supplementary angle. This pair of angles is called supplementary angles. Now, to remember this, you can say, there is a tip. So, when you are saying something right, okay, when you are saying something right, you get appreciated. You did a good thing. People will say like that. So, you get complimented. You get complimented, right? So, in mathematics, right means 90. In geometry especially, we will refer a 90 degree angle as a right angle, like that. So, right means 90 for us mathematicians, right. So, 90 degree, so you can remember this. If you are saying something right, you get complemented. So, right complemented. So, 90 degree complemented when the sum complementary. So, remember it like this, guys. Now, let us see something fun. Okay. So, complementary angles are the angles which are when there are two angles and then when the sum is 90 degree, exactly 90 degree, we call it as complementary angle. When the sum is exactly 180 degree, we call it as supplementary angles. By the time this comes up, let's wait. So, we will see a pair of sum. So, here we have 55 degree and 35 degree. So, sum is 90 degree. So, now I am going to change this 46. Now, 36 and 54, sum is 90 degree. So, what happens now? 84 degree and 4 degree, again the sum is 90 degree. So, these are complementary angles. So, complementary angle again 32 and 58. So, again now what happens? 23 degree and 157 degree, sum is 180 degree. So, you can see. So, when it is 73 degree, it is 107 degree. This pair is always supplementary, it is set in that way. So, you have 57 degree and 120 degree, sum is 180 degree. So, that is complementary angles. So, let us go back to our presentation. Okay, now adjacent angles. What do you mean by adjacent? Adjacent means being near. So, here in this figure you can see that 40 degree and 50, these two angles are near. See, they have a common vertex, they have a common arm and their non-common arms are lying on both the sides. That is the definition for complementary angles. Adjacent angles. Two angles are adjacent if they have a common vertex. So, here we have a common vertex, a common arm, this one, and non-common arms, that is these two. The arms which are not common, they are on either sides of the common arm. So, this will be in middle always. Now, look at this collection. Are they adjacent? They do not have a common arm, they do not have a common vertex, and none of the conditions are satisfied. So, this pair is not adjacent. Now, what about this? This will be an adjacent angle because there is a common vertex, there is a common arm, and the non-common arms are either lying on the both sides of the common arm. Now, here there is no common arm, there is no common vertex, and none of the conditions are satisfied. So this collection is not adjacent. Now, can you tell me, in the first figure, is that adjacent? So here is a common vertex, here is a common arm. So these angles are, angle A and angle B are adjacent. What about this? Here we have a common vertex, but there is no common arm. So this is not adjacent. And here we are having a common arm. So this is a common arm, but there is no common vertex, so they are not adjacent. And what about this figure? In this figure, we are having, see, we are having a common vertex, we are having a common arm. See, this is common to both the angles A and B. But what about the non-common arms? Are they lying on either sides of common arm? Is it in the middle? No, you can clearly see that non-common arms are lying in the right side. Non-common arms are lying in the right side. So this pair of angles, angle A and angle B, are not adjacent. So whenever two angles overlap, we say that they are not adjacent. Okay. Now, can you draw two adjacent angles in such a way that their non-common arms form a line? So adjacent angles, you have to draw two adjacent angles. So if you are drawing an angle like this, so you can draw an angle like this. So these are adjacent angles. So these are adjacent angles. Now we have to draw an adjacent angle in such a way that non-common arms, so this is the common arm here, this is the common arm here. So the non-common arms should lie in the same line. So here this is the figure, right? Such a pair of angles are called linear pair of angles. So remember, linear pair of angles. For two angles, so we say a pair. So two angles are said to be a linear pair of angles when they are adjacent as well as their non-common arms should form a line. That is, the sum of, when the sum of two adjacent angles becomes 180 degree. We can define it again. When the sum of two adjacent angles are 180 degree, we can call it as linear pair of angles. So when the sum of two angles are 180 degree, we call it as linear pair of angles. Now, are supplementary angles always a linear pair? So supplementary means the sum of two angles will be 180 degree, and a linear pair means the angles should be adjacent as well as the non-common arms should form a line. Or we can say that the angles should be adjacent and the sum of the adjacent angles should be 180 degree. So can you draw? If you are thinking we can draw, all supplementary angles are a linear pair, then you are wrong. Because you can draw supplementary angles like this also. But are they a linear pair?